Hi everyone! Today we're going to take a look into how we can solve a quadratic equation. So let's first look at this graphically. We saw this graph in our previous video. It's the graph of a quadratic function, also known as a parabola. Well, we also know what x-intercepts and y-intercepts are. X-intercepts are when our graph crosses the x-axis, so that would be right over here and right over here. And my y-intercept is when my graph crosses the y-axis, which would be right over here. Well, we can actually get a lot of information about the solutions to our quadratic function from our x-intercepts. This is one way that we can find the solutions to our quadratic function. By looking at the graph, if we see where our x-intercepts are, they're going to give us the answers to our quadratic function. So these can either be called our solutions, and sometimes they're also called the zeros. And this is because at our x-intercept, that's when y is equal to 0. And to understand this a little bit more, let's take a look at the standard form of a quadratic equation. So over here, I have our standard form, ax squared plus bx plus c is equal to 0, where a, b, and c are all constants. If you see here, we've equated this entire equation to 0. So we're basically equating y to 0, which is why if we look back over here at our graph, when y is equal to 0, those are going to give us the solutions to our function. The main method that we're going to take a look at today for solving quadratic equations is factoring. Now, when we're factoring quadratic equations, there are actually two separate ways that we do it, and it depends on how our standard form looks like. Today, we're going to factor equations when a is equal to 1. So when this constant is equal to 1, that's the type of factoring that we're going to be taking a look at today. So let's take a look at the example below. X squared plus 6x plus 9 is equal to 0. So here, let's take a look at what all of my constants are equal to. We have our a value over here, which is equal to 1, b, which is equal to 6, and c, which is equal to 9. So when we're factoring a quadratic equation, what we want to do is we want to take a look at our constant c over here, and our goal is to factor it in such a way that when we add both of the factors of our c constant, they are going to add up to our b constant. So let's take a look at the different ways that we can factor the number 9. Well, we can have 1 times 9, and we can also have 3 times 3. So when I add the factors 1 and 9, I get, 1 times 9 is 9, but when I add the factors, I'm going to get 10. And 3 times 3 is also equal to 9, but when I add these factors, I'm going to get 6. So, since our goal is for our factors to add up to our b value, and since our b value here is 6, we know that the factors that we're going to be using are 3 and 3. So I'm going to write this right under the 9, and I'm going to factor it using the tree method and write 3 and 3 to show that this is how I'm going to be factoring it. Now we need to set up our factored form, and this is how we're going to do it. We're going to have 2 sets of parentheses, like such, and we're going to have an x at the beginning. Now what we're going to do is we're just going to plug in these numbers into our factored form. Well, if we take a look, this is a positive 3 over here, so I'm going to write plus 3, and our other factor in this case happens to be a positive 3 as well. So I'm going to write this as plus 3. So now I know that my factored form of this equation is x plus 3 times x plus 3, as is shown here. Now, we need to remember that in the beginning, we actually equated this equation to 0. So this is actually equal to 0. And we're going to be using this when we're thinking about how we can solve for the x value. So what you're going to do now is you're going to take each of the parentheses that we've grouped. So I have one set here, and then I have my other set over here. So what I'm going to do first is I'm going to look at this first set, x plus 3, and I'm going to set just this x plus 3 equal to 0. And I'm going to do the exact same thing over here. I'm going to set this x plus 3 equal to 0. Now, in this case, we're looking at a problem where both of our factors are 3, and so both of our solutions are going to come out to be the same. However, this might not always be the case. In this case, it just works out to be like that. So now I'm just going to solve for x. So I subtract 3 on both sides and get x is equal to negative 3. And I do the same thing for my other factor. I subtract 3 on both sides and I get x is equal to negative 3. Now again, since my factors were the same, my solutions are also the same. So in this case, this specific quadratic function has one solution, and that is x is equal to negative 3. So when we look at this graphically, I'm just going to use this same graph over here and draw a separate parabola. We know that our solution is going to be x is equal to negative 3. And again, we also know that when we're looking at a quadratic function's graph, when we're looking at the actual parabola, it's going to be such that the x-intercept of our parabola will represent the solution of that equation. So now that we know that the solution to this quadratic equation is going to be x equal to negative 3, let's see how this would look on a graph. I'm just going to connect these lines again since I erased the previous graph. So we know that it's going to be x is equal to negative 3. Now, when you only have one solution, as you have over here, to your quadratic equation, your parabola is just going to sit on the x-axis. So the solution, if this is where negative 3 is, the parabola would be sitting here. This would be the vertex of our graph. And our graph would look a little something like this. And this is how you factor a quadratic equation and find its solutions when your a constant is equal to 1. To get more personalized tutoring and to practice online using practice assessments, make sure to check out Prepaze.com. I'll see you all in my next video.